It is in the idea of man that we need to unravel and figure out the things around us as exactly as conceivable. What applies on a limited scale can obviously likewise be applied to the higher perspective. For ages, space experts have been excited to get a handle on the entirety of the universe and all of its qualities. Anyway, specialists are stood up to with a tremendous issue in this regard. From our natural vantage point, it's just unrealistic to review the whole universe. But does this optical impediment likewise imply that we won't ever have the option to arrive at the finish of the universe? What's more, does something like this even exist? We should plunge further into this intriguing point today. But before we begin, recall to leave us a like and a subscription in order to join us in the future in looking for the largest mysteries of the universe. Music. The subject of the end of our view to the stars is restricted. A great many divine bodies that radiate at us in the atmosphere in no way, shape, or form reflect the entirety of the universe. That piece of space that we can see from our home planet is properly called the discernible universe. Against the background of the cosmological principle, which states that the universe generally presents itself to the observer in the same way, no matter what his area and course of observation, there is a round space around the Earth, the volume of which corresponds to our grandiose field of view. The optical obstruction which restricts our view into the depths of the universe is known as the perception horizon. This is that grandiose region from which information has contacted us since the birth of the universe, which occurred around 13.8 billion years ago. Anyway, this doesn't imply that the distance to the perception horizon is also 13.8 billion light-years. In this regard, we should consider the consistent extension of the universe, which makes distances expand. Thus, our cosmic view is around 46.6 billion light-years from us. With this data toward the rear of our minds, we should grasp the reason why the absolute interpreting of the universe presents itself as, some would say, an impossible endeavor. To approach the question mentioned at the start, whether it is feasible to find the end of the universe or indeed, even to reach it, we must first answer another, more key question. Is there such an incredible concept as an end of the universe at all? Can a being, which is just too readily called a boundless structure, have an obvious outer edge? The revealing answer to this question is, we have no clue about this. This is fundamentally because the shape and volume of the universe are still a great unknown. Speculations in this respect range from a round universe to a flat, boundlessly larger one, to a wide variety of mathematical shapes, like that of a donut or a trumpet. Likewise, we should recall a significant reality when guessing about the shapes and aspects of the universe, which depend essentially on its shape. Endlessness is not equivalent to unboundedness. In other words, this means that regardless of whether the universe has a limited volume, it doesn't imply that it can't be endless. To illustrate this proposition, we should take a look at the frequently used ant model. If one somehow happened to put the little ant on the surface of a sphere, it would run for any length of time toward any direction under the sun without ever encountering a defined edge. Consequently, it would seem to the bug as though it were continuing on an infinitely large design, despite the fact that this is obviously false in the case of an inflatable. Right now, it should be noted that this is a very simplified model which only serves us in beginning to understand. Because, in contrast to the inflatable, the universe is not embedded in a higher layered space within the traditional cosmology, multiverse, and big freeze. Some scientists answer the question of whether the universe has an edge or an end with a decisive yes. Anyway, the foundation of this answer is not as straightforward as it might appear at first. In detail, this assumption is based on the theory of chaotic inflation, presented in 1986 by the Russian cosmologist Andrei Linda. The core of this theory states that our universe does not represent the entirety of everything, but only an imperceptibly small link in an endless chain of further subuniverses. Thus, the majority of the universe would continue to grow in an inflationary manner since the Big Bang, by which this development came to a halt only in some bubble-shaped fractional regions. So, each infinite world could contain its own values of the regular constants and, therefore, totally different physical laws. Hypothetically, it's even possible that the individual fractional universes can come into contact with one another. Anyway, the question concerning the end refers not only to the spatial, but also to the existential level of the universe. Regardless of whether the speculative scenarios of the Big Bang, crunch, huge tear, and large freeze vary from one another exhaustively, the larger part of specialists concur that the universe will arrive at its end some far-off day. Our current research suggests that the extension of the universe will proceed with endlessly from now on. Against this background, the proposal of the large freeze seems to be undoubtedly the more likely scenario. The universe, as it extends, will become colder because the impact of dark energy speeds up the development of the universe. As indicated by our current state of knowledge, the space between individual worlds will continually increase too. Subsequently, photons will ultimately be redshifted beyond recognition. When the gas for the formation of new stars is spent and the already existing heavenly bodies go out, the universe will change slowly into a position of dark, cold emptiness. Assuming that the proton is unsteady and decays, the remaining parts of the once shining stars will also be deleted from the cosmic world. All that will be left then are black holes. If the last gravity beasts were dissipated by Hawking radiation, the temperature in the universe would become uniform. Since thermodynamic work is no longer possible, the heat death of the universe is fixed. The end, as a beginning, however, wouldn't be the end of the story. People wouldn't be people if our interest in another question weren't stirred. Here, what happens then in the main second? A further occupation with the subject appears pointless after our normal understanding. An end generally implies an absolute end. In this regard, anyway, some specialists assume that the astronomical end doesn't necessarily mean an irreversible end, but instead clears the way for the introduction of a new universe. Consequently, the fact that the universe is cyclical makes it conceivable, dependent upon a consistent pattern of decline and climb, by which the change point of this mood can't be known as a Big Bang but maybe a big bounce. Exhaustively, this means the defining moment in a continuous cycle of contraction and expansion. Despite the fact that this speculation doesn't necessarily fit into standard cosmology, more and more researchers are moving away from the idea that the much referred to Big Bang actually marked the start of existence. The most extraordinary proof for the theory of a primordial cosmic detonation is the location of the cosmic microwave background radiation, truncated as CMB. This remnant from the primitive eras of the universe is isotropic and fills the whole universe. Anyway, the microwave background also represents an enticing riddle for specialists. Regardless of where researchers point their radio telescopes, the radiation always seems identical, even in regions that could never have interacted with one another at any point in the past 13.8 billion years. Thus, astronomers expect that the corresponding regions must have been connected in the past, with a mechanism that adjusts the temperature across the whole observable universe. The fluctuations in different regions would need to be much higher. One possibility to resolve this so-called homogeneity problem is proposed by inflation. During a time of crazy expansion, the universe stretched so extremely fast that most of it ended up beyond the regions we can observe today. Although the inflation hypothesis best fits the data gathered so far, it is not without its criticisms. According to it, we don't know the conclusive mechanism that triggered the inflationary growth, and it's also difficult to explain what led to the smooth stopping of this cycle. The inflationary hypothesis makes several predictions that, so far, have not worked out. To break out of the outdated cosmological shackles, specialists like Paul Steinhardt decided to say farewell to the inflationary hypothesis and pursue new approaches. Another point of view is that the most concerning issue of present research is the adherence to an incontestable Big Bang hypothesis. Traditionally, the introduction of the universe is interpreted as the process in which space, time, and matter arose out of a singularity. However, the Big Bounce hypothesis rejects this fundamental notion. According to it, the Big Bang was not at all the start of existence but rather a defining moment or a transition point from a previous stage where space contracted. If we now replace the bang with a bounce, the distant regions of the universe would have had enough time to interact with each other and form a single smooth universe, in which the sources of microwave background radiation had the opportunity to adjust. According to Steinhardt, it's possible that time has always existed. And if it has always existed, Then why shouldn't there have been multiple such cycles? The obvious conclusion is that such a bounce could also repeat itself in the future, when the expanding universe begins to contract and returns to a uniform, dense state. The big cycle could then be set in motion again. Now it's your turn. What are your thoughts on these ideas regarding the spatial and existential end of the universe? As usual, drop us your thoughts, ideas, and feedback on the present video in the comments below. Are you in the mood for more interesting contributions on the subject of space? Then take a look at other videos on our channel, which we have linked for you here in the credits. Gratitude for your interest. Take care, and we'll see you sometime later.